Welcome to Learning Anatomy with Dr. Bakare. In this lecture, we'll be looking at the portal vein. In this lecture, I'll be unfolding the basics that you need to know about the portal vein as students of anatomy. Portal vein is also referred to as the hepatic portal vein because it is related to the liver. And as we go through with this lecture, we'll see how the portal vein is so related to the liver. It is the main vessel of the portal venous system. The portal venous system is a collection of veins that are responsible for carrying nutrient-rich blood to the liver, where it will be used up to produce substances that are needed in the body. So we have a number of veins that carry deoxygenated blood, but nutrient-rich blood to the liver. So you see collection of blood from the gastrointestinal tract, from the gallbladder, from the pancreas, and also the spleen. And they are being directed into the portal vein. And from the portal vein then delivers it to the liver. So you see deoxygenated blood, but nutrient-rich blood being carried from the gastrointestinal tract, from the gallbladder, the pancreas, and also the spleen. And this blood that is deoxygenated but rich in nutrients is then directed through the portal vein. So this is the portal vein here, arrowed, and this will further deliver the blood into the liver. So going further and explaining on the importance of the portal vein, why is the portal vein created? Where is there the need to carry nutrient-rich blood to the liver? So in our previous slide, we've established that the portal vein carries deoxygenated blood. And we know that deoxygenated blood is supposed to be delivered into the inferior vena cava, which is the collection point for venous blood at the lower part of the body, which will further merge with the superior vena cava to form the vena cava that will then deliver this deoxygenated blood into the right side of the heart, which will then further be delivered into the lungs where it will be oxygenated. That is the normal route. But for the portal vein carries deoxygenated blood, but the blood that is deoxygenated, that is being carried by this portal vein, is rich in nutrients. And these nutrients are being extracted from the gastrointestinal tract and also its surrounding organs. So as we ingest food substances and also as digestion occurs, the nutrient that is extracted from this food is then collected into the portal vein, which then delivers it to the liver. So that is how that occurs. So what is the essence of this? Why is this deoxygenated blood, although nutrient-rich, not delivered into the inferior vena cava? Because it is deoxygenated and, of course, should normally be transported or delivered into the inferior vena cava for it to further go into the heart. But this is not what is seen in this kind of presentation. This deoxygenated blood, but nutrient-rich blood, is delivered into the portal vein, so that the portal vein can further release it into the liver. And what the liver uses it for is as raw materials for it to manufacture, so to say, a number of substances that are being produced in the liver, which is then released to the body for body functions. So you have the portal vein here, arrowed in white, and this portal vein is seen to collect nutrient-rich blood from the gastrointestinal tract and also the organs that are related to it. And it, of course, delivers it to the liver. This blood, we say, is supposed to be directed into the inferior vena cava. This is the inferior vena cava here behind, that is arrowed in yellow. The inferior vena cava is known to collect venous blood from the lower part of the body. And if we try to look deep on the functions of the liver, we see that the liver presents a number of metabolic functions, and this includes detoxification, also the production of bile, which is used for the emulsification or the breakdown of fat. It is also involved in the production of proteins such as albumin and so on. All these substances need raw materials for them to be produced, and this is what the liver takes up in the nutrient-rich blood that is being delivered by the portal vein. So that's the relevance or the importance of the portal vein, because it helps to collect nutrient-rich blood from the gastrointestinal tract and also the organs that are located around that region and delivers it into the liver, because we know the liver presents a number of metabolic activities as we've highlighted. So it uses up this nutrient to manufacture its own substances, then it then further releases into the body for the body to function normally and also effectively. So going further, let's look at the formation of the portal vein. How is the portal vein formed? First, the portal vein is about 8 centimeters in length, and it is formed by the union of the splenic vein and also the superior mesenteric vein. So this is the splenic vein. You can see the splenic vein is a vein that drains the spleen, and at this point, you see it uniting with the superior mesenteric vein. And this is the superior mesenteric vein here. And when these two veins unite at this point, they form the portal vein. And this is the portal vein here, arrowed in red. So we can say that the portal vein is formed by the union of the splenic vein and also the superior mesenteric vein. And if you look at the pattern by which the splenic vein and also the superior mesenteric vein unite to form the portal vein, you see that it is approximately at about an angle of 90 degrees. And this is what is highlighted here in yellow. And after this union, they now become the portal vein. And the portal vein, you see, it is being directed towards the liver because it's going to be supplying the liver with nutrient-rich blood, although the blood is deoxygenated. If you try to look for that, the portal vein is formed between the neck of the pancreas anteriorly. This is the pancreas here highlighted in green. The pancreas is made up of the head, the neck, the body, and also the tail. This is the neck region of the pancreas here, arrowed in white. And if you look at it, you need to cut off the neck region of the pancreas for you to be able to see the region where the formation of the portal vein is created. So the neck of the pancreas is seen to be anteriorly related to the point where we have the union of the splenic and also the superior mesenteric vein to form the portal vein. Posteriorly, what is seen behind the region where the portal vein is formed is the inferior vena cava. And this is the inferior vena cava here, arrowed in black. So we can say that the formation of the portal vein is bounded anteriorly by the neck of the pancreas, and posteriorly it is bounded by the inferior vena cava. It's also good for us to know that the portal vein is not a true vein, and it's also valveless. What this means is that if you look at the normal configuration of arteries and veins, if you've not checked up my lecture on the differences between the arteries and veins, please kindly go and check up that lecture so as to keep yourself updated. We say in that lecture that arteries generally carry oxygenated blood and also blood that is rich in nutrients, while veins carry deoxygenated blood and blood that is not rich in nutrients. But in the case of the portal vein, even though it is carrying deoxygenated blood, but this blood is rich in nutrients. So carrying blood that is rich in nutrients is not the normal scenario of what is presented in the other veins in the body. It is also seen to be valveless. Arteries generally are seen to be valveless because the blood in the arteries flow under high pressure. So there is no need for the creation of valve. So arteries are valveless, while veins are seen to contain valves because the blood within the veins are flowing under low pressure, and there is need for the creation of valves so that blood can be directed in a single path. And that is why we have valves created generally in veins. Valves are not seen to be located within the portal vein and also its tributaries. So this kind of differences that the portal vein presents, when you try to compare it to the normal configuration that is seen in the other veins in the body, you see that it is not a true vein in this regard because it is seen to be carrying nutrient-rich blood, and it is also valveless, which is not seen in the other veins that are seen in the body. So going further, let's look at the tributaries of the portal vein. The portal vein, we know that it is formed by the union of the splenic vein and also the superior mesenteric vein. So we have major tributaries of the portal vein. And the major tributaries to form the portal vein, which are the major vessels that are seen to unite to form the portal vein, as we've described in our previous slide, are the splenic vein, and this is the splenic vein. You see the splenic vein merging with the superior mesenteric vein, and this is the superior mesenteric vein. At this point, they merge to become the portal vein. These two veins are the major tributaries of the portal vein. This is not to say that the portal vein does not have other tributaries. It has some minor tributaries, because after the union of the splenic and the superior mesenteric vein to form the portal vein, there are also other veins that are seen to drain into the portal vein, and these are also taken as its tributaries. But this will be classified for easy understanding in this lecture as the minor tributaries. So let's go further to see the other veins that are seen to drain into the portal vein, which means that they will be draining deoxygenated blood, but nutrient-rich blood into the portal vein. So after the formation of the portal vein by the union of these two vessels, we also have a number of veins that are seen to also drain into the portal vein, and this include the right gastric vein. This is the right gastric vein. The right gastric vein is seen to run towards the right side of the lesser curvature of the stomach, and it is also seen to also receive another vein. And the vein that it receives is the prepyloric vein of Mayer, and this is the prepyloric vein of Mayer here highlighted. So this vein is also seen to drain into the right gastric vein, while the right gastric vein will then be seen to drain into the portal vein. We're actually gradually creating the portal venous system. So let's write down and see the other veins that are seen to also drain into the portal vein. The second vein is the left gastric vein. This is the left gastric vein. The left gastric vein runs towards the left curvature of the stomach, and it drains region of the stomach around that space. This also receives another vein, and this is the esophageal veins. So we have esophageal veins at the lower 1/3 of the esophagus, and these are also seen to drain into the left gastric vein. This left gastric vein will then be drained into the portal vein. So you can see how the portal venous system is gradually being created. Then the third vein that is seen to drain into the portal vein is the cystic vein, and this is the cystic vein here. Cystic vein is the vein that drains the gallbladder. We know that the gallbladder is located close to the liver because it is a storage tank for bile that is produced in the liver, and so it is located close to it. So we have the gallbladder around this region. So we have the cystic vein also draining the gallbladder. So this also releases the venous blood into the portal vein. But the specific region of the portal vein that it releases this venous blood into is the right branch of the portal vein. And this is to tell us that the portal vein at a point after its formation will divide into the right branch and the left branch. So this is the right branch here, and this is the left branch. So the right branch is what receives the venous blood from the cystic vein. Just for us to know this, in case we're asked during examination that the cystic vein is drained into the portal vein, at times you need to be specific. So the specific region of the portal vein that it drains into is the right branch of the portal vein. Then the next vein is the paraumbilical vein. This is the paraumbilical vein here, arrowed in blue. The paraumbilical vein is also seen to drain into the portal vein. Hence, it is one of the tributaries of the portal vein. And it is also draining into specific area. And the specific area that it is draining into is the left branch of the portal vein. Remember, we said that on the right branch of the portal vein, we have the cystic vein. On the left branch of the portal vein, we have the paraumbilical vein. And this is what drains into the portal vein, but the specific region of the portal vein that it drains into is the left branch of the portal vein, because we say that the portal vein, after its emergence and formation, will be dividing into the right branch and the left branch. Then the next minor tributary of the portal vein is the superior pancreatico-duodenal vein, and this is the superior pancreatico-duodenal vein. This vein is also seen to drain venous blood, which is deoxygenated blood, but blood that is rich in nutrients will be delivering this blood into the portal vein. So now we can see that the tributaries of the portal vein is very interesting. And as we highlighted the major and the minor tributaries of the portal vein. For the major tributaries, we already know that there are two major tributaries, and this includes the splenic and also the superior mesenteric vein. For the minor tributaries, which are also tributaries, are drained also into the portal vein, but are not involved in the structural formation of the portal vein. So they are seen to drain into it, hence they are classified as the minor tributaries of the portal vein. And this is what we've highlighted here. So going through this slide, you should be able to establish or explain, in case you have during the exam, the tributaries of the portal vein. Going further on the tributaries, it is also good for us to highlight the sub-tributaries of the portal vein. We've highlighted in our previous slide the tributaries of the portal vein. The tributaries include the major tributaries, the splenic vein, and also the superior mesenteric vein. These two veins are also seen to have sub-tributaries, and this is what we'll be classifying in this slide as the sub-tributaries of the portal vein. So if you go back to our previous slide, we already established that the portal vein is formed by the splenic vein. This is the splenic vein here highlighted, and we have the superior mesenteric vein. These two veins will unite at a region approximately at 90 degrees to form the portal vein. And this is the portal vein here. We already established that we have major tributaries and we also have minor tributaries that are also seen to drain venous blood, but deoxygenated blood into the portal vein. So for the major tributaries, these major tributaries, which include the splenic vein and the superior mesenteric vein, they also have sub-tributaries, like secondary branches that are seen to also drain venous blood, but nutrient-rich blood into these veins. And this is what this slide will be highlighting. So for the first one, the splenic vein, we have the pancreatic veins. The pancreatic veins are seen to drain the pancreas, and this is what is arrowed here. You see them up here and you see them also down here. So you see them draining into the splenic vein. And these are like the sub-tributaries of the major tributaries that we've highlighted before in our previous slide. So if you are following, you see that this is gradually being unfolding, the configuration of the portal venous system. So the second vein is the short gastric veins. These are the short gastric veins, and these are seen to drain the fundus of the stomach and also the upper part of the stomach. And this is what is harrowed here in red. Then the next vein that is seen as a sub-tributary of the splenic vein is the left gastroepiploic vein or the left gastroomental vein. And this is the left gastroepiploic or the left gastroomental vein. This is also seen to drain nutrient-rich blood into the splenic vein. And the next one is the inferior mesenteric vein. And this is the inferior mesenteric vein here highlighted in black, draining the organs that originates from the hindgut. So we should also look forward to sub-branches of the inferior mesenteric vein. There are also a number of veins that will be draining into this inferior mesenteric vein. So let's write down to unfold this. This is the inferior mesenteric vein. Remember that it is the superior mesenteric vein that unites with the splenic vein to form the portal vein. So the inferior mesenteric vein unites with the splenic vein before the splenic vein finally unites with the superior mesenteric vein to form the portal vein. So that is the kind of pattern that is seen around that region. So for the inferior mesenteric vein, because it drains different regions or organs that are formed from the hindgut, we should expect that it would have its own sub-tributaries or secondary branches that will be draining into it. So the first one is the left colic vein. This is the left colic vein here, highlighted in green. The left colic vein will drain the descending colon. Then we have the sigmoidal veins. These are the sigmoidal veins here, highlighted in black. This is seen to drain the sigmoid colon. Then we have the superior rectal vein that is arrowed here in black. We know that the superior rectal vein, if you go back to our lecture on the rectum, if you've not also checked that lecture, please kindly go and do so. In that lecture, we stated that the superior rectal veins are drained into the portal venous system, while the middle and the inferior rectal veins are drained into the systemic drainage. So this is where that is established. If you look at the superior rectal vein, yes, one of the sub-tributaries of the inferior mesenteric vein, and this is what finally drains into the splenic vein. So you see that truly the superior rectal vein is seen to drain into the inferior mesenteric vein, which finally unites or drains into the splenic vein. The splenic vein is then seen to merge with the superior mesenteric vein to form the portal vein, which finally delivers this nutrient-rich blood to the liver. While the middle and the inferior rectal veins are seen to drain into the internal iliac vein, which finally drains into the inferior vena cava. So that we go through the systemic venous drainage, while the superior rectal vein is seen to drain into the portal venous system. So that is where that is established. Now we've highlighted the different secondary tributaries of the splenic vein. So you see that the splenic vein is not just seen as a standalone vein, it is also seen to receive branches from other structures that are located around it. So for the superior mesenteric vein, the superior mesenteric vein is what unites with the splenic vein to form the portal vein, as we've established. The superior mesenteric vein also has its own secondary branches that drains nutrient-rich blood into it. And the first one is the inferior pancreaticoduodenal vein. This is the inferior pancreaticoduodenal vein. Remember the superior pancreaticoduodenal vein. This is the superior pancreaticoduodenal vein. And this vein is one of the minor tributaries of the portal vein. We described this in our previous slide. So the corresponding named vein at the inferior part is what is seen as a secondary tributary of the superior mesenteric vein. So we have the inferior pancreatical duodenal vein. Then following that, we have the right gastroepiploic or right gastromental vein. And this is the right gastroepiploic or right gastromental vein. Remember, we also have the left gastroepiploic or left gastromental vein. And this is what is harrowed here. But this is seen to drain nutrient-rich blood into the splenic vein. So we have the right gastroepiploic vein here as a secondary branch of the superior mesenteric vein. And this is followed with the middle colic vein. This is the middle colic vein here. Then we have the right colic vein. This is the right colic vein highlighted in black. Then we have the intestinal veins, which include the jejunal and the ileal veins. And these are the jejunal and the ileal veins here highlighted in black. Then finally, we have the ileocolic vein. This is the ileocolic vein here. So you see that we have a number of veins that are also seen to drain deoxygenated blood, but nutrient-rich blood into the superior mesenteric vein. So finally, this is what the configuration of the portal venous system looks like. You can see that we have major tributaries, we have minor tributaries. The major tributaries also have their own secondary tributaries. So now going further, let's look at the part of the portal vein. After the formation of the portal vein, by the union of the splenic and also superior mesenteric vein, the portal vein is formed. So what part does this portal vein run before it finally reaches the liver, where the liver will be able to take the blood up and use the nutrient contained within each up as raw materials to produce its own finished product. We said that the portal vein is formed behind the neck of the pancreas. This is the neck of the pancreas here, and behind this is where we have the formation of the portal vein. And the portal vein is formed by the union of the splenic and also the superior mesenteric vein. And as it is formed here, anteriorly, it is related to the neck of the pancreas. Posteriorly, it is related to the inferior vena cava. So this is what we have at the back. This is the inferior vena cava. So you see the inferior vena cava down, descending down. And as it descends down, you see it being placed behind the region where the splenic and the superior mesenteric vein unite to form the portal vein. So we see that anteriorly we have the neck of the pancreas, and posteriorly we have the inferior vena cava. So after its formation, you see that the portal vein ascends up, and as it ascends up, it is seen to be located behind the first region or the first part of the duodenum. This is the duodenum here, highlighted in red. We know that the duodenum is formed as a continuation of the stomach. So that means the stomach will be somewhere around this region. So after the stomach, we have the duodenum. And we know that the duodenum is configured in a C pattern. I've also done a lecture on the duodenum. If you've not checked that lecture, please kindly go and do so. This is the duodenum here, highlighted in red. And we know that the duodenum is a C-shaped structure. And because of this C-shaped pattern of the duodenum, it is being divided into 4 sub-regions. We have the superior first part, we have the descending second part, we have the horizontal third part, and we have the ascending fourth part. So the part that is related to the portal vein, after its formation, as it courses upward to meet the liver, because it's going to be supplying the liver with nutrient-rich blood, it is seen to be positioned behind the first superior part of the duodenum. So in case we are asked during exam that the specific region of the duodenum that is related to the portal vein is the first or the superior part of the duodenum. So this is what we have here. After passing behind or crossing behind the first or the superior part of the duodenum, you see it ascending up and tailing towards the porta hepatis. The porta hepatis is like an indentation that is created at this region of the liver. It's like the hilum of the liver, through which structures pass through to enter or exit the liver. So you see the porta hepatis around this region, and this is where the portal vein is directed towards, because that's the only access it has for it to access the liver, because it's going to be delivering deoxygenated blood, but nutrient-rich blood to the liver. And it's also good for us to know the placement of the portal vein within the porta hepatis, because we have a number of structures that are passing through this region to access the liver. So let's say this is the configuration of the porta hepatis. This is the anterior part, and this is the posterior part behind. This is the right side, and this is the left side. So where we have the portal vein is at the posterior region, and this is what is highlighted here in blue. So this is the portal vein that is seen at the posterior part or at the posterior region of the porta hepatis. So in the anterior part, towards the right region, we have the common hepatic duct, and this is the common hepatic duct that carries bile. This also needs to pass through the porta hepatis because it's going to be transporting bile that is produced in the liver to be stored in the gallbladder. Then on the anterior side still, but on the left side, we then have the hepatic artery proper. And this is the hepatic artery proper here that is highlighted in red. So it's good for us to be able to establish the position of the portal vein. So also using this image up here, this is where we have the portal vein. So if you look at it, portal vein is seen at the posterior part. It is located behind at the posterior region of the porta hepatis. Then if you come more anteriorly on the right side, you have the common hepatic duct, and this is the common hepatic duct here that is transporting bile that is produced in the liver and to be stored in the gallbladder. So this is the part that it runs, and this is seen in the anterior part, but more to the right. This is the right side, and this is the left side. So on the left side, in the anterior side, what we have is the hepatic artery proper, and this is the hepatic artery proper. The hepatic artery proper is a subdivision of the common hepatic artery that emerges from the celiac trunk. So that is how it goes. It's good for us to be able to establish the position of these different vessels within the porta hepatis. So finally, what is then seen is that the portal vein will divide into the right branch and the left branch. So this is the right branch of the portal vein, and this is the left branch of the portal vein. So this is how they finally divide to supply the different lobes of the liver. We know that the lobes, we have the right and the left lobe, and posteriorly we have the quadrate and the quadrate lobe. So they go down to supply the different regions of the liver. So going further on this, is good for us to also establish the morphology of this branch. We know that finally the portal vein will divide into two branches. We have the right and the left. The right branch, this is the right branch. It is shorter than the left. It is also more vertical. And of course, we know in our previous slide that it receives veins from the gallbladder, which is the cystic vein. So you have the cystic vein, of course, draining its deoxygenated blood and also nutrient-rich blood into the right branch of the portal vein. This we've established in our previous slide. Just for us to know that this right branch of the portal vein is shorter than the left, it is also more vertical. While the left branch is longer, as you can see, this is the left branch. It is longer than that of the right. It is also smaller in caliber, and it is oblique. If you look at the position, it is obliquely placed. And also, we've also established in our previous slide that it received the paraumbilical vein, and this is the paraumbilical vein. We said that the specific region of the portal vein where we have the paraumbilical vein drain into is the left branch of the portal vein. We already stated this in our previous slide. So it's good for us to also highlight it here where we're describing the branches of the portal vein. So this is what we have here. So if you look at this configuration, you see that the right branch is shorter, while the left branch is longer. And because it is longer, it sure needs a form of structural support, and that is what will be taking us to the next point. If you look at the left branch of the portal vein, you see that at the upper part, it is supported or connected with the ligamentum venosum. And the ligamentum venosum is a remnant of the ductus venosum. And this is what is seen to structurally support the left branch of the portal vein at its superior part. So if you look at it at the inferior part, it is also supported by ligament that's referred to as the ligamentum teres. And this is the ligamentum teres here, arrowed in white. The ligamentum teres is a remnant of the left umbilical vein. So during developmental process, the left umbilical vein is created, and this vein later becomes obliterated and then transformed into embryonic remnants, and it is then tagged as ligamentum teres. So this ligamentum teres is seen to structurally support the left branch of the portal vein at the inferior part, even though they are embryonic remnants, but here they are seen to perform the function of creating support for the left branch of the portal vein. So it's good for us to also note this interesting activities that is exhibited by the ligamentum venosum and also the ligamentum teres. So let's look at the intrahepatic part of the portal vein. We know that the liver is divided into lobes, and the lobes are further subdivided into hepatic segments. We have the right and the left branches of the portal vein accompanying the right and the left branches of the hepatic artery. This is the right lobe and this is the left lobe. So this is the right region and this is the left region. And of course, we know that the lobes are further subdivided into hepatic segments. So we have the hepatic artery proper. This is the hepatic artery proper, dividing into the right and the left hepatic artery. We know that the hepatic artery will be supplying the liver with oxygen-rich blood. So this is also going through the porta hepatis and is going to be delivering oxygen-rich blood to the liver. So you see the portal vein and the branches that emerge from it being accompanied by the hepatic artery. And this is what is presented in this image. So you see them, they go side by side. While the hepatic artery will be supplying oxygenated blood, the portal vein will be supplying nutrient-rich blood. So they go side by side. As one is supplying oxygen-rich blood, the other one is supplying nutrient-rich blood to the different hepatic segments. And of course, we know that the portal vein will divide into the left and the right branches. So for the left branch, you'll be seen to supply the first to the fourth hepatic segment. So this is the left branch of the portal vein. This is the portal vein here, highlighted in blue, and this is the left branch. You see it's going towards the left lobe, and finally it will subdivide to supply the first to the fourth hepatic segment. And this is what is seen in this. So it supplies the first, the second, the third, and the fourth hepatic segment. So it is supplying nutrient-rich blood to this region of the liver. While we have the right branch of the portal vein, this is the right branch of the portal vein that is highlighted here in yellow. You see it, it is directed towards the right lobe, and it will be supplying the fifth, the sixth, the seventh, and the eighth hepatic segment. So you can see that each of these branches, after dividing into the right and the left branches, they further divide to supply the various hepatic segments that is formed as a sub of the different lobes of the liver. So that is what is presented generally. As you see that the left branch supplies the first to the fourth hepatic segments, while the right branch of the portal vein will supply the fifth to the eighth hepatic segments. So it's good for us to also be able to establish this into branches that will further supply the different hepatic segments. They are finally drained into the hepatic sinusoid. The hepatic sinusoids are like hepatic microcirculation. So they are like spaces that are created, and within this space, we have a number of cells that are lined within the cavities or the lumen of the sinusoids. And these cells have different functions. So we have the normal endothelial cells seen to line the wall of the vessels. So you see the endothelium, then you see the hepatocyte, which is the main cell of the liver that is responsible for liver metabolic activities. Then we have the Kupffer cell and the stellate cell. So if you look at the lumen, this is the sinusoid. We have the endothelial cells here highlighted in blue. We have the hepatocytes here highlighted in black. You have the stellate cell that is highlighted here in red. Then you have the Kupffer cell. The stellate cell and the Kupffer cell are of immune function. And we have the normal endothelial cells of the blood vessels that are seen to line the wall of the blood vessels. Then you have the hepatocytes, which is responsible for carrying out liver metabolic activities. So within the sinusoid, you have different types of cells that are involved in different types of functions. And this sinusoid is fed with nutrient-rich blood from the portal vein. This is the portal vein here, arrowed in red. So we have the portal vein carrying nutrient-rich blood to supply the sinusoid, and it goes in, and the different cells are involved in different functions, and they begin to pick up what they need from the nutrient-rich blood that is supplied by the portal vein. Then you have the hepatic artery. The hepatic artery is also seen to deliver its oxygen-rich blood into the sinusoids because they also need oxygen to survive. That is what they use to produce energy for them to be able to carry out the different activities that they will be exhibiting. Then you have the bile duct to transport bile that is used for the breakdown or the emulsification of fat. So this is the different structure that are seen around the sinusoids. And after which, and the nutrient that is contained within the blood that the portal vein is bringing is taken up and used up by the liver cells. Also, the oxygenated blood that is being delivered by the hepatic artery is also being used up to carry out their metabolic activity. So what is now left is now deoxygenated blood and also blood that is not rich in nutrients. This is then further delivered into the central vein. So this is the central vein here. The blood is then further transported or delivered through the hepatic vein. This is the hepatic vein here, harrowed in black. From the hepatic vein, it is finally delivered into the inferior vena cava. And this is the normal systemic venous drainage of the body. You can see that the portal vein is so created so as to deliver nutrient-rich blood to the liver, where it uses its pulp, and the remaining blood is still further redirected back into the inferior vena cava. So the essence is just to provide nutrient-rich blood to the liver, where it can use its pulp as raw material to continuously produce its own products. So you can see that the liver has a dual blood supply. It has supply from the portal vein, which supplies nutrient-rich blood to it, and it also has supply from the hepatic artery, which supplies oxygen-rich blood. So the supply of about 80% of blood is coming from the portal vein, while the supply of about 20% of the blood is coming from the hepatic artery. So let's quickly look at this slide. This slide talks about the relations of the portal vein. This should come easy because we've highlighted some of these points in our previous slide. So in the anterior part, the structures that are located anteriorly to the portal vein include the neck of the pancreas. So this is the neck of the pancreas. So the pancreas at the neck region will need to be opened up for us to see where the portal vein is formed. So it is seen as an anterior relation. Then we also have the first or the superior part of the duodenum. This is the superior part of the duodenum, or the first region of the duodenum. We've also described this in our previous slide. We say after the formation of the portal vein, it ascends up, and in the course of ascending up, it is seen to be located posterior to the first or the superior part of the duodenum. So this is also seen as part of the anterior relations of the portal vein. Then going further, we have the common bile duct. This is the common bile duct. The common bile duct is formed by the union of the cystic duct and the common hepatic duct. And as they descend down, they become the common bile duct. And in this space, they are seen to be located anterior to the portal vein. Then the next structure we have is the hepatic artery proper and also the gastroduodenal artery. So this is where we have the celiac trunk. We know that the celiac trunk supplies organs that originate from the foregut. So this celiac trunk is further subdivided into the left gastric artery, the splenic artery, and also the common hepatic artery. And this is the common hepatic artery here, arrowed in yellow. It is this common hepatic artery that further subdivides into the hepatic artery proper and also the gastroduodenal artery. So this is the hepatic artery proper here, and this is the gastroduodenal artery. So these two arteries are seen to part anteriorly, or seen at the anterior part of the portal vein. So you see them parting through, and in this course, they are seen to be positioned in the anterior part of the portal vein. So if we now go further on the posterior relation of the portal vein will then be the inferior vena cava. This is the inferior vena cava here, harrowed behind. The inferior vena cava is known as a collection point of all venous blood at the lower part of the body. And as it parts down, it is seen to be positioned at the posterior part of the portal vein. So let's check our understanding of this lecture through the following questions. And the first one will be to explain the formation of the portal vein and also the path towards the portal hepatis. This we have adequately described during the course of this lecture, how the portal vein is formed and how it parts upward to reach the portal hepatis. Then the second question will be to highlight the major / the sub-tributaries or secondary tributaries of the portal vein. The third question is to describe the relations of the portal vein. And the last question will be, what is the relevance or the importance of the portal vein? We should be able to highlight this as we adequately describe it during the course of our lecture. Thanks for watching. Let's continue to stay glued to this channel. Thank you. Bye.